All right, so I'd like to take a look at another example of using the distance formula. So let's say we had the ordered pairs negative 3a and 2 negative 4a. So we had two options before if we wanted to find the distance between these 2 points, and that was either to use Pythagorean theorem or the distance formula. But to use the Pythagorean theorem in this case would prove to be kind of hard because we don't know the values of a here, so we don't know where we would be able to plot these on our coordinate plane, which means that we're kind of stuck using the distance formula. We don't really have a choice. So remember that the distance formula is d equals the square root of the quantity x sub 2 minus x sub 1 squared plus the quantity y sub 2 minus y sub 1 squared, right? It's just the difference in our x coordinates and the difference in our y coordinates. So I'm going to call this x sub 1 y sub 1 and this x sub 2 y sub 2. Those are my points. So let's plug into the distance formula. So we have d equals the square root of, so we take the difference of our x coordinates, so it's 2 minus a negative 3, 2 minus a negative 3, that quantity is being squared, plus the difference in our y coordinates, y sub 2 minus y sub 1, so negative 4a minus a, that quantity squared. So now simplify. So remember when you're subtracting two negatives, that becomes addition. So we have d equals the square root of, so 2 plus 3 is 5, so this is 5 squared, plus negative 4 minus a, that's a negative 5a squared. And then simplify. So 5 squared, that's 25, so we get d equals the square root of 25, and then plus negative 5a squared, so we square both the negative 5 and we square the a. Negative 5 times negative 5 is positive 25. A times a is just a squared. So we end up with 25 plus 25a squared, the square root of all of that. And this is actually our final answer. I know that since both of these are perfect squares, some of you might be tempted to take the square root of each individual term and get something like 5 plus 5a. But we'll actually show that these are not equal, right? So 25 plus 25a squared, the square root of this, is not equal to 5 plus 5a. And if you want to see that that's true, try taking 5 plus 5a and squaring it by doing FOIL. FOIL it out, and you'll see that you won't get this result. So our actual result is what we started with, or what we got up here, 25 plus 25a squared.